Today, I'm going to show you how to solve parities without law and algorithms. First, I'm going to show you all the parities, so you kind of familiarize with those, and all the parities for normal Rubik's cubes, with normal Rubik's cubes being 4x4, 5x5, so on. But I'm going to use the 4x4 cube as an example here because it has all 4 of the parities. We can apply these types of solving the parities with a 5x5 or larger cube. I'll start by saying that three of the parities can be solved in the same fashion. So I will start with those, then cover the last one. But first, so you can familiarize yourself, I'm just going to show you all the parities. This is the first parity. It's where this edge is swapped with this edge. They're swapped like this. So they're swapped across from each other. Let's move on to the next. Here's the second. It's where two edges are swapped adjacently. And this one's gone here, this one's gone here. Next. Here's another. It's where two corners need to swap. And the next. And last is the notorious edge parity. It's where two edges are actually flipped. And the three from before, that's 4 parities. The three from before actually can all be solved in a very similar fashion, where this one is totally different. On the top of the screen, you can see the pattern that you have to follow if you want to solve this parity, where two edges are swapped diagonally. And I'm going to have the move on the screen in case you get lost, so you have something to hold on to. But so we're going to start this case with the two edges we have to swap like this. So the first one is over here, and then the other round one is in the back. And so we first do a double right slice turn. So that means like this. Double right slice turn. So 1, 2. And now from now on, every time after we do a move, we're going to do a double slice turn after it. Okay? So next comes a U2. And now we need to do a double slice turn after it. And then a UW2, like this. And then we do a double right slice turn. And then just move this top middle layer twice. And as you can see, in between each move we did a double slice turn, right slice turn. So that's how you solve that parity. This one's similar, but instead of the edges being across from each other, they are adjacent. So now, this is going to make a lot more sense if you watched my setup move video, which you can see on the screen. That I go really into depth on what these setup moves are, but our setup move will be placing these edges across from each other so we can use the same move to swap them, okay? So that means we need to move this one back, then this one up. And now we do the same move we did before to swap these two by doing a double right turn, a U2, double right turn, UW2, double right turn, and top like the inside layer on the top. And now we aren't done that yet because we need to undo our setup moves by moving this back side back, then moving this side back. And now that's actually moved the edges into the right place. They're just flipped. Okay, so how can we unflip these two? Well, this is actually can be done with a very simple 3x3 or Rubik's Cube algorithm, which just flips two edges since this is not a parity actually. And how we're going to do it is we're going to treat the 4x4 cube as a 3x3. So imagining these middle layers are stuck together. And now let's do it. So we bring this one down, move it over here, keep it safe, so we move this one up, move this back, then bring the middle down, move the bottom 180 degrees, bring the middle up, move this one in, bring the middle down, move the bottom 180 degrees, bring the middle up, move the bottom back, bring the middle down, move the bottom back, bring the middle up, then undo the U-turn, and boom, we've solved that parity. So feel free to watch that again, because that's a little bit tricky to solve. But now for the next one. And now for the swap corner case. So this one can again be solved in a similar way, but it's a little bit trickier. So first we're gonna start with a 3x3 move. That actually, you probably know it. It's where, if you're using the beginner method, you have two corners that are together. You connect them to their side, have them facing away from you, and then do this move. It actually essentially swaps these two corners. Well, we're gonna do that. Now we can do the same 3x3 move to swap these two, and that goes the middle twice, top clockwise, counterclockwise. Sorry, middle twice, top counterclockwise. Then we bring the middle down, then twist the top 180 degrees, move the middle twice, move the top twice, bring the middle down, then move the top twice. And that solved everything apart from the same case that I showed you first, which was we have two adjacent edges switched, or across edges switched. And this can be solved in the exact same way. And remember the pattern, every right turn, so every we start with a double right slice turn, and this is the way I remember it, and then every other turn we have a double right slice turn. So I'm going to show you it. So we have the round one facing towards us, and then the back, and double right slice turn, top twice, okay, and then we need to do this, and then both the top and middle layer twice, then double right slice turn, and there we go. So it's solved. It's essentially swapped those two corners. Now it's also very hard, but if you watch the video, or watch this part maybe twice or even more, it will make a lot of sense to you. So now for the last case. And now for the final case, the notorious edge parity. So this is actually very difficult to solve, but I'll explain it as well as I can. So there's a long algorithm you can do for this, but I'm going to tell you that you don't actually need that. There's just a pattern that you follow that will get this solved. It's a little bit long, but it's better than the algorithm. So what we do is, I'm going to say every one of these turns is associated with a double top turn, okay? So if I did this, I'd have to do a double top turn, okay? That's part one of the pattern. Then part two is every time I do this, I have a double front turn. And that's part two of the pattern, and that's essentially it. So now let's actually solve it. So we have the edge facing towards us, okay? Then we bring the right down, and that's associated with a double top turn, so we do that. Then we bring the left down, and that's associated with a double front turn. Bring the left up, that's associated with a double front turn. Okay, and now we move the right twice, and then the right is associated with a double top turn. Then move the right once upwards, and that's associated with a double top turn. Move the right down, again associated with a double top turn. And then this is where it gets a little bit different, and the pattern isn't totally accurate, but we do a double front turn, even though there was no left turn. Then a double right turn, and a double front turn, and it's solved. Boom. That's it. Feel free to watch the video again to get a better grip on this subject, but bye.